Okay, in this section of Algebra 2, we're going to learn how to solve absolute value equations. They're a little tricky, so we're going to start with just the basic understanding of what an absolute value is. So, an absolute value of a number is its distance from zero on a number line. Now, generally speaking, distances are positive. In fact, they are positive. We can actually get negative answers here when the negative sign is not inside of the absolute value bars. The absolute value bars look like those straight bars on both sides of that -3. So to illustrate, I'm going to put a scale on here of 0 there and 5 there. And we're going to, first of all, color in that -3. And you're wondering how far that is away from 0. So it's 1 space, 2 space, 3 spaces away from 0. And we would say that the absolute value of -3 is 3. Some people tend to think of the absolute value as being just a mechanism for making things positive, and it's very useful in that regard. But there's more information, and it is pretty simple to do until you get up into different types of numbers where the numbers are combinations of two parts. You'll get to those when you learn imaginary numbers later. Okay, absolute value of 6. Let me do this in red color. 6 is up here. And if you count the spaces in between there and that 6, the 0 and the 6, you get an absolute value of 6. So a simplistic but actually very useful way of thinking of absolute value is that it forces negative numbers to be positive, but it forces positive numbers, well, it doesn't change them. Since they're already positive, forcing it to be positive is sort of a waste of time. Okay, the next one here, I'll do this one in black. The absolute value of 0 is actually 0, since the number 0 is right up on top of 0 and there's no distance between them. Okay, so our first absolute value equation is this one. We're trying to find a number whose absolute value equals 4. Now, I will show you the results of this, and I'll point out a few features of these problems. Here's a scale. Since we could put a 4 in there, and for x, the absolute value of 4 is actually 4. I'll show you what that looks like. One of the answers we get is x equals 4. Now, the other number whose distance from 0 is 4 units away would be the one in the other direction, in other words, -4. And if I take what I had right here, I can modify it slightly, and you'll see that this also works. There's what I had, and if I multiply this number by -1, you'll see I get a -4 in there. And -4 also has an absolute value of 4. So I can either put the value of x, or I can multiply it by -1 in there, and I'll get two separate values. This here is -4. So let me show you how that would work. You come over here and you make an exact copy of what you had before. And you multiply this by -1. Now, what that ends up giving here is -1x equals 4, and if you divide by -1 on both sides, you'll get your other answer. Now, this is a little different way of doing it. You'll be a little confused by it at the start. It's a little different way than some teachers do. I'm a little unique in this regard. But I have discovered over the years that my method, it prevents a lot of extra work for students because they learn one way to do it for all of these notes, we're going to eventually switch from equal signs to inequalities. And if you were in another teacher's class, they'd probably teach it differently and you'd have a lot of memorizing to do. Okay, I'm going to take a little side note here that's really important. It's on this, just printed here. That's the distributive property. It doesn't work with absolute value bars. So you're used to doing this with parentheses, and you multiply across, and you would say 3x plus 12 there. But the problem with that, well, these absolute value bars are not the same as parentheses, even though they are a grouping mechanism. They have more function than just grouping. They force that result, that x plus 4, to eventually become a positive number. Okay, so since x cannot be both 4 and negative 4 at the same time, this is a choice, you're going to have an or in the middle here. And what I'm going to do to summarize here is tell you that with the absolute value equation, where you have an equal sign, it's an or split. You can see I put the word or in the middle there. And the first copy is exactly the same as we started with, but you drop the bars. And then I want you to erase this. This is me doing the old method. Make a second copy of that. And simply multiply this by negative 1. Now what this does is put both x and the opposite of x right inside of there. And they both, when you put absolute value bars around them, mean the same thing. If you think about the absolute value of negative 1, it's positive 1. Now if you divide both sides here by negative 1, you'll end up with your final answer here of x equals the opposite of n. Now don't skip to this step. Show the intermediate here. Strong advice. Okay. Now I will highlight for you that we got two answers. All right, so the steps, I want to put this as clearly as I can, so I've given you 3 steps to do. The first step is you always have to isolate the absolute value portion of it. So in other words, in this example, we have to get that absolute value section of it all by its lonesome. And we're going to do that first by adding 5 to both sides. And then we're going to get rid of this 3 on the outside. And the temptation here is to distribute because those look like parentheses, but they're not. So you have to get rid of the multiplication by dividing. And then they cancel off. So that takes us down to the isolated version of this. Like that. Okay, and then you need to split up the absolute values using OR and solve both equations. A lot of people will put the first one down. They'll say, okay, 2x minus 4 equals 6. And you can kind of imagine putting a 6 in place of the stuff in green. Okay? And they don't bother to do the other half of the problem. Well, it's actually a pretty easy procedure. You copy what you just wrote down again. And you simply multiply this left-hand side here by negative 1. So we'll solve the first one over here first. That gives us 2x equals 10 when we add 4 to both sides. And we'll divide by 2 here. And that'll give us x equals 5. On the other one, now that we do have parentheses, we'll distribute. Subtract 4 from both sides. And divide by negative 2. Okay, there is another another step that you have to do. You need to check your work. Now, I strongly advise checking your work as often as you know how, but here you really do have to check it because it will give you wrong answers, this process that I'm teaching. So you get all the way down to the bottom and you actually might have wrong answers. These answers that are fakes are called extraneous answers. You can abbreviate that with the first 4 letters. It's not an extra answer, it's an extraneous answer, meaning a false answer that you can't trust. So we're going to try this 5, and if it works, we'll indicate that with a check mark. If it doesn't, we'll cross it out gently. I don't want to obliterate it, and we'll put EXTR there to say don't trust this answer. So we'll put a 5 up here. 2 times 5 is 10. 10 minus 4 is 6. The absolute value of 6 is still 6. 6 times 3 is 18. 18 minus 5 equals 13. So that was an example of a legitimate answer. And we'll have to check this -1. So first of all, -1 times 2 is -2. -2 minus 4 is -6. The absolute value of -6 is +6. 6 times 3 is 18. 18 minus 5 is also 13. So we have 2 legitimate answers on this problem, and I'll pick up on page 2 in the next video.